Hey everybody, and thank you for coming to the PM3 YouTube channel. This is going to be an instructional video on segmentation and centerline extraction of blood vessels. And I developed this method specifically for cerebral aneurysms. Before I get started, I'd like to thank Lawson, Canarie, and Western University for supporting this research. So I'm just going to walk you through the image processing pipeline. Now, what this is a general outline of the processes that you're going to have to go through to get your segmentation and your centerline extraction. So first, you're going to have to load your images. This may seem very basic, but it can sometimes present some issues that I'll walk you through. Next is the actual segmentation, the centerline extraction, and then finally you're going to have to export your results into some sort of file. Now I'm just going to walk you through a bit more specifically the method with a bit more detail. First, loading the images. Now your medical images can come in many different types of formats: DICOM, PNG, TIFF, and a variety of other types of formats. I would say the most common format is a DICOM image. However, some programs can tend to have problems loading in DICOM images if the what's called the DICOM header is not in the correct format for this program. Now, what you can do to deal with this problem is you could find an application that can handle these types of problems. For example, MATLAB is quite good at handling DICOM headers. You could also edit the DICOM header manually using a program that can do that. Or what some scientists will do is they'll just omit these problem data sets. Next is segmentation. There are a few different methods of segmentation. One is manually drawing the regions of interest. And basically this entails drawing the shape around your region of interest in every slice of your medical image. This can be fairly time consuming and is not always the most accurate depending on the training of the person who's doing it or some variety of other factors. Next is thresholding, and this is basically setting a certain brightness value and saying anything above this brightness value is going to be within my desired volume, and anything below is going to be outside of the volume, or vice versa. And there are some slightly more advanced versions of thresholding that I'm not going to get into. And this can be a fairly good method for segmentation, but depending on the contrast of your image, won't always work out perfectly. And finally, what we have is region growing. And so what this is you'll choose a seed point or many seed points within your desired volume, and this can be manual or using something like a threshold. And then what's going to happen is using an algorithm, these seeds are going to grow in volume until they reach the border of your desired feature. And yeah, it's going to iteratively grow within your desired feature, ideally until the entire feature is filled. And that's what we're going to be using today. Now, centerline extraction, there are quite a few programs that have centerline extraction capabilities. And basically what this is it's going to be drawing a line down the length of the blood vessels within your image. And this has applications for blood flow simulations and a few other Few other applications. Some programs that can do this are SimVascular, ImageJ, VMTK, and MATLAB. Within this video, I'll be showing you how to do this in MATLAB using a function called bwskel, which is part of the Image Processing Toolkit. And finally, exporting the files. Segmented images should usually be exported as a binary volume. And this may be a set of DICOM images or another format such as VTK, PNG, TIFF. And I would stay away from JPEG because these are compressed image formats, and so you can lose some of your resolution. And the Centerline, in my process, it will be exported as just a plain ASCII text file with a list of the coordinates within the Centerline. Now I'm going to walk you through my specific implementation, each of the steps that I took, and showing you my MATLAB code. My MATLAB code uses some functions from the Image Processing Toolkit, which is great. It has lots of capabilities for processing DICOM and other medical images. My script is partially manual, meaning that I have some interactions with the MATLAB GUI, as well as a lot of parameters that can be adjusted to suit any individual needs, whether that be adjusting thresholds, anything to deal with your specific geometry or contrast level or anything. And what my MATLAB code does is it loads in some DICOM images, processes it, and then exports as a binary PNG image stack and a list of centerline coordinates. First, to load the image, what these first lines do is it just opens up the folder containing my DICOM images. These second lines here are going to create a list of all the files within this folder. And then down here, what I'm doing is I'm creating a matrix the same size as my image matrix. And I'm reading in each of the image files into this im matrix. Now for the segmentation, using a region growth algorithm. First, what I'm doing is I'm creating a list of seed points using a threshold. So anything above brightness 45,000 is going to be a part of my seed point mask. And then I'm using the function BW, or active contour, which is a MATLAB function that basically is a region growth algorithm. I'm using the Chan-Vess algorithm for region growth. There are a couple other ones that are available, but I found this one to work the best. I'm running it for 300 iterations. Basically, this is how many iterations it is going through a region growth process. I found 300 to work for this. It depends on your seeds, how many of them there are, and how big your volume is, how many iterations you're going to need, and also the dilation bias. The dilation bias determines how the tendency of the algorithm to go outside or inside of the border of the feature that you are trying to segment. I found that 0.17 gave me a fairly good